says you have 9.81 times 10 to the fourth moles of aluminum nitrate. How many grams do you have of aluminum nitrate? Aluminum nitrate, can't write very clear here. All right, so the first thing you have to do is we do this a conversion problem, right? Remembering moles into grams. First we have to determine is the chemical formula. You gotta put all the English into chemistry terms. So what's the chemical formula for aluminum nitrate?
Al.
Okay.
3.
Aluminum. And what's nitrate?
Is NO and then -3.
NO3
Oh,
has
just
-1.
okay.
And aluminum's +3, right?
+3.
Aluminum's in that +3 column on the periodic table, and nitrate is a polyatomic ion, which has a -1 charge. So how would the formula be written for aluminum nitrate?
So it's gonna be Al and then NO3 and
Okay.
then plus a 3 parentheses.
Parentheses 3. Yep. So in order to go from moles to mass to grams, we have to know what? We have to know the molecular weight of the compound. So you have to determine the molecular weight of aluminum nitrate to solve this problem. So we know aluminum. Let me pull my periodic table here. We have 1 aluminum. We have how many nitrogens?
3.
3 nitrogens. And how many oxygens?
Is this 6?
No,
Oh, 9.
9, right? You have 3 sets of NO3, so there's 9. So aluminum weighs 27. So we have 1 times 27. We have 3, let me do it this way, nitrogens. Nitrogen is 14. And we have 9 oxygens. So we end up with 1 times 27 is 27. 14 times 3 is 42, right? Yeah, 42. And 9 times 16. Ooh, I put oxygen here. This should be 16. Function 16 times 9 is 6 again here. Math part. 9 times 16. Let's clear this. Equals 144. Okay, so we add those together, you got molecular weight. 13, 3, 7, 11, 213 grams per mole. Is that what you got?
Oh, I got 215.
What did I do wrong? I did something wrong. 27. Let's see, 3 nitrogens. So we had 27. And then nitrogen is 3 times 14. 42.
Oh, that's 27.
Yeah, 27. Aluminum is 27, right?
Okay, I thought it was a 29.
Oh, okay.
Yes, you're right. 213.
Okay, so 213 grams per mole. So now we can solve our problem. We have 9.81 times 10 to the 4th moles. And we just calculate the molecular weight, how many grams we have per mole. So we have 213 grams per mole. Make sure our units cancel, moles cancel. That's right, 213 on top. And this unit here is equal to 1. 1 mole of aluminum nitrate is the exact same thing as 213 grams. So that equals 1. So we take 9.81. 9.81 times 213. It's going to equal. And how good are we at this? We are at 2.08953 times 10 to the third. And then we're going to use our exponent here. This is going to be times 10 to the fourth. And we're getting 3 significant digits. So we're good to here. So it rounds up. So our total answer is going to be 2.09 times 10 to the 7th grams. That all make sense?
Yes.
Okay. So it's just a simple conversion that we've done before. This goes from moles to grams using the molecular weight. All right, so calculate how many grams of calcium phosphate will form. Okay, so when I calculate the calcium phosphate, you know, one of the products of calcium phosphate. If 347.0 grams of iron 3 phosphate is mixed with 285 grams of calcium fluoride. Okay, so what we need to do is take all this information from English into chemistry. So we have the reaction. Okay, it says we're mixing iron 3 phosphate. So what is the chemical formula for iron 3 phosphate? Iron 3 phosphate is iron, right?
Yes. Fe.
And phosphate, PO4.
PO4.
Phosphate's a polyatomic ion. It says iron 3. So we know the charge on iron is 3 plus. Charge on phosphate is what?
-3.
-3. So there you go. So no subscripts are needed, right?
Yes.
3 plus and 3 minus balances. Plus calcium fluoride. Calcium is Ca. Fluoride is L.
2
What's the charge on calcium?
+ 2
And what's the charge on fluorine?
-1.
Okay, so we have to put
CaF2.
CaF2. Then draw a line. And we know it's going to, because we got ions. So we're going to form, what's the iron going to form with?
It's gonna be Fe and
Right.
then F3.
Iron 3 fluoride. Exactly right. Iron is a +3 charge because we were told that, and fluoride is -1. Plus calciums can combine with what?
Ca
Okay,
and then F2.
not F. That's what we started with.
Calcium, phosphate.
Calcium phosphate,
So it's gonna be PO4.
right?
Also, would it be Ca and then 3 PO4 2?
Yep, exactly. There's your chemical formula. Okay. You converted the English into chemistry. Now we got to balance it. Once you have an equation, once you have any kind of chemical equation, we have to balance it. So how do we balance this?
Can we put a 2 on next to the Fe on the left?
Okay, again, there's two Fe, yeah, the Fe is balanced and the PO4s, there's 2 on the right. So let's put a 2 here to get 2 PO4 groups, right?
Yes.
Then what do we do?
And then can we put a 3?
In front of where?
Okay.
In front of what?
Calcium on
Calcium.
the left.
Yep. Because there's 3 calciums on the right. All right, so we got the phosphates and calciums to balance. Now I get let's do the irons. How many irons do we have to put?
Oh, 2 on the other side as well.
Okay. So let's check. 2 irons on the left, 2 on the right. 2 PO4 groups on the left, 2 on the right. 3 calciums on the left, 3 on the right. 6 fluorines on the left, 6 fluorines on the right. So we're balanced.
Okay.
And then let's finish what we with our equation acids are. It says we're going to, how many grams of calcium phosphate will form? So we want to know this. This is our question in grams. And will form if 347.0 grams of iron 3 phosphate. So this one we have 347.0 grams. And calcium fluoride, calcium fluoride is mixed with 285 grams of calcium fluoride. 85 grams of calcium fluoride. All right. So we got all our information right in front of us now. We've converted everything from the question into a chemical formula. All right. So we know we're going to need molecular weights of FePO4, calcium fluoride, and calcium phosphate. We need those molecular weights to be able to, we have to get everything into moles. Okay. It has to go to moles to use the chemical equations. It's not math or anything else. It's in moles. It says 2 moles of iron phosphate is going to react with 3 moles of calcium fluoride to produce 2 moles of iron 3 fluoride and 1 mole of calcium phosphate. So we have to go to moles. So iron, let's do FePO4. Is iron weighs what? Let's look up periodic table. Iron weighs 55.855. Yeah, let's say 55.9. Let's go to 56. Let's just round it off here. Iron is 56. Phosphorus is how much?
30.9.
30.9, so 31. And oxygen is 16, and we have 4 of those, so 64. So the molecular weight of iron phosphate is going to be 151 grams per mole.
And then, so for Fe, it's not going to be times 2. That one doesn't matter.
Which it doesn't matter.
The 2.
No, that's a coefficient.
Okay.
That's just how many you have in the chemical equation. The molecular weight is only on the substrates inside the formula itself. There's one iron, 1 Fe, 1 P, and 4 oxygens. Okay, the 2 only refers to how it's going to react in the equation, not the molecular weight of the compound.
Okay.
That makes sense?
Yes.
All right, so for the next one, we have calcium. Okay, how many calciums do we have?
1.
Perfect, we have 1 calcium, and calcium is 40.
40.
And we have how many fluorines?
18.9. Oh, we have two, sorry.
Yep, we have two fluorines, and fluorine is 19.
19.
So that's 38, right? We have two of them. So we have a total of 78.
Plus 40.
It's the molecular weight. And we also need to know calcium phosphate. Because we deal with those three compounds we're dealing with, you have to have all three of their molecular weights to go to moles. Okay, so we have calcium, which we know is
40.
right? And there's three of them, right?
Yeah.
So 40 times 3 is 120. Phosphorus, how many phosphorus do we have?
31, and then we have 4. What? One, sorry.
No. How many phosphorus do we have in calcium phosphate?
Oh, 2.
Two. We have two phosphorus, and each one is 31, like you said. So it's 62. And how many oxygens do we have?
8.
We have 8. So 16 times 8 is equal to 128. So we have 2, 3, 9, 11, 310. So now we have the molecular weights of all three compounds that were going to be involved in our conversion here. Okay, any questions so far? Okay, now because we have two components, we have a measured amount of iron 3 phosphate and a measurement of calcium fluoride. One of those is going to run out first. So you have to determine your limiting reagent. So in order to limiting reagent, we have to convert to moles. Right? So iron phosphate, iron 3 phosphate, we have 347.0 grams. Okay. And we know there's 151 grams per mole. That's going to get us moles. And for calcium fluoride, we have 285 grams. I want to convert that into moles. And one molecular weight is 78 grams per mole. So we determine the moles of each of the starting compounds that we have, and then we're going to compare them to the ratio in the chemical formula instead of a simple ratio and determine which one's going to run out first. So we have 347 divided by 151. That equals 2.2, we've got 4 units, 2.298. Right? And for calcium fluoride, we have 285 divided by 78. That equals 3.65, 3 significant digits. Okay. So now all we've done is converted each of the masses of what we started with into moles. So we're going to set up our ratio to see which one's going to run out first. So far, so good?
Yes.
All right, perfect. Now, which one do you want to pick?
Calcium.
Okay. You got it. Let's pick calcium fluoride. Let's set that equal to X. So we'll take 2.298 over X. So that's our calcium fluoride, or iron phosphate over calcium fluoride.
Calcium. Oh shit, yeah.
Okay. And what's the ratio going to be?
Is it 2-to-1?
2, because we use the subscripts right here. This is the subscript for iron phosphate. This is one for calcium fluoride.
2-to-3? Okay.
Yep. So it's exactly 2 over 3. Okay. So 2x cross multiply equals 2.298 times 3. So x equals 2.298. 2.298 times 3 divided by 2. So that equals 3.45. Okay. Now X was equal to calcium fluoride. So we look here. Do I have 3.45 moles of calcium fluoride?
Yes.
I have more, right?
Yes.
So that's going to be an extra. So what the limiting one is going to be iron phosphate. Okay. Because I have extra 3.45 and 3.65. So I have extra calcium fluoride. Make sense?
Yes.
Okay, so now we're limiting reagent. So now we know which one we have to use in our calculations. Because that's when it's going to run out first. Once that runs out, the reaction stops. So it's going to limit how much calcium phosphate we can produce. So we already got moles. So let's start a new equation with we already did that calculation. So 2.298 moles of iron phosphate. Okay, so moles of iron phosphate go on the bottom. And from iron phosphate, I want to go to moles of, what am I looking for? I'm looking for calcium phosphate. Okay, look at my ratio. Moles of iron phosphate is 2. Moles of calcium phosphate is 1. So now I got moles of calcium phosphate. I want to go back to grams, see how much is going to be produced. That's what the question was asking me. Okay, I already calculated the molecular weight. So I know I have 310 grams of calcium phosphate per every mole of calcium phosphate. Make sure everything cancels. So moles of iron phosphate, moles of iron phosphate, moles of calcium phosphate, moles of calcium phosphate. And make sure each one of these is equal to 1. We got 2 moles of iron 3 phosphate, and we got 1 mole of calcium phosphate, our balanced chemical equation. And we know that the molecular weight of calcium phosphate is 310 grams for every 1 mole. Okay, so we get out a trusty calculator. And we say 2.298 divided by 2 times 310. Comes out to 356. And we're only good to 4 significant digits, right? Yeah. So 3562. Oops, I want to be back in. right color. So 356.2. So we have 356.2 grams of calcium phosphate is going to be produced when we mix those two numbers together. Does that make sense?
Yes.
Those are the most, those are the problems most students miss. Because there's a lot of steps involved.
Also, the first step would be to like change it into like chemistry form.
Right?
And then after you balance it, and then you put in molecular weight.
For the ones that are involved, yep.
And then you do the limiting range.
Limiting reagent.
And then after you do the ratio, and then you solve it.
Right. That's it. That's the steps involved.
Okay.
Got it?
Yes.
All right. Perfect. Like I said, those are tough ones because they're just long. This one will give you possible different answers. All right. So on a warm day, let me just make sure we're still recording because I'll put all these on that website so you can still get back in and look at them whenever you want. Sure. I got the last two I got to put on still. Yeah, it's still recording. Okay. On a warm desert morning, you go for a Sunday drive where you pass 15 cactus farms. If you average 55.7 miles per hour on your Harley Davidson during your Sunday drive, how far in meters will you travel in 3.5 hours? Okay. Now, most people are going to put in that number 15 just because they see a 15 there. And that makes no difference to the problem, right? 15 cactus farms makes no difference. So you don't use the 15. Like I said, I'll put in street addresses, things like that, and people always put those numbers in. Because you just look at numbers and put them all together. So let's say what we got. We've got 55.7 miles per hour. Hard is during Sunday. How far are you going to travel in 3.5 hours? So we're starting with 3.5 hours, right? That's what we're starting with. Okay. So what goes on the bottom? Hours are on top. So what's on the bottom to cancel?
Oh, hours?
Hours. So we're going 55.7 miles per hour. So every hour we're going 55.7 miles. Okay. That's how many miles we're going to go. So I'm now in miles and I want to get to meters. So I got to go from English to the metric system. 1 mile, like I said, you can use multiple conversions here, but 1 mile is 5,280 feet. I know that because that's the one I convert with. Okay. So now we've gone to feet. So feet, you have to go on the bottom. There's 3.28 feet per meter. Now I could have gone from miles to meters directly. I could have miles to kilometers, kilometers to meters. Like, there's multiple ways to do it. This is one of the ways to do it. And that got me into meters. Let's double check everything. Hours, cancel. Miles, cancel. Feet, cancel. Make sure each one of these unit conversions here is equal to 1. There's 55.7 miles every hour, right? We're averaging 55.7 miles per hour. So 55 miles, we're going to travel in 1 hour, okay? There's 5,280 feet in 1 mile. The same thing. And there's 3.28 feet per meter. So each one of those 3 units are multiplied by 1. So all we do is converting, not changing the value. So we take our hand-in calculator, 3.5. On the top, you multiply, the bottom you divide. Times 55.7 times 5,280 divided by 3.28 is going to equal 3 point, what are we, where are we at? 3 centimeters measured in miles. So 3.14 times 10 to the 5th meters.
Okay.
We actually have that answer. There's letter D. Was that the one you had questions on?
Yes, because what I did is I did kilometers,
Right?
but I didn't add the hours, the 3.5 hours. I was gonna add it after, but then it still didn't add up.
Yeah. But the best way to do these problems is write down what you're starting with. We're starting with 3.5 hours. Now we're not starting with, how do you know you're not starting with 55.7 miles per hour? Because that's your conversion. Miles per hour is conversion. It gets you from hours to miles or from miles to hours. So you're starting with 3.5 hours. That's your single value. Does that make sense?
Yes.
Okay. How many nitrogen atoms does the compound ammonium nitride contain? So we got to find out the formula, chemical formula for ammonium. Nitride. IDE ending. Okay. What's ammonium?
NH4.
NH4, and that's a +1, right?
Yes.
And then nitride is what?
Nitride. Would it be just, isn't it just like nitrogen, but for +2?
What do you mean +2? It'd be nitrogen, right? Because the ID ending is just nitrogen.
Yes.
What's the charge on nitrogen?
Nitrogen is -3.
-3. Okay.
Oh,
So NH4 3 times and then nitrogen. The IDE ending means it's just the element.
okay.
A couple exceptions. Okay. So there's your formula for ammonium nitride. And the question is, how many nitrogen atoms does it contain? So how many nitrogen atoms are there in ammonium nitride?
So do you just add them up?
Yep. So how many total nitrogen atoms are there in there?
Mm. How do I know?
Okay. Well, here's your nitrogen atoms, just so you do the molecular weight. Here's your nitrogen atoms, and here's nitrogen atom. So this is 3 groups right here on this first one. So there's 3 here, 1 here. So nitrogen has 4, hydrogen That's 12. So there's 4 nitrogen atoms and 12 hydrogen atoms. So NH4 3 times means there's 3 nitrogens plus there's another one for the on the side there. Just like if we're looking at acetic acid, if sometimes you put the formula CH3COOH, we'll write that for organic chemistry. If you look at that, that has 2 carbons because you add them all in there, 4 hydrogens, and 2 oxygens. Just add them inside the formula. So for nitrogen, it would be 4 for the ammonium nitride.
Okay.
Does that make sense now?
Yes.
Okay.
Just 4?
Yeah, because there's 3 right here, the arrow pointing, and then 1 right here.
Okay. Yes.
There'd be 4.
Okay.
Okay, does that make sense now?
Yes.
Okay, perfect. All right, while exploring the wonderful desert in Joshua Tree, you find an arrowhead among the rocks. You need to determine the density to prove its authenticity. So you need to determine density. So density is equal to mass over volume. Okay, the arrowhead has a mass of 0.438 pounds and the temperature of 28 proof hydrogen centigrade. You then fill a graduated cylinder with exactly 50 milliliters of water. When you place the arrowhead in the water, the volume of water rises to 52.35 milliliters. What is the density of the arrowhead that we can determine? Okay. So we know mass and volume. We know the mass is equal to, where we go, 0.438 pounds. Okay. So we need to convert that into grams, 250 grams per milliliter. Okay. And the volume, we put in the graduated cylinder, the volume rises up to 52.3. So the total volume was, we had total volume in the cylinder of 52.35. And we started off with 50.00. Okay. That equals 2.35 milliliters. That's what our question is telling. We don't need the 28.5 degrees centigrade. That makes no difference. Okay, so far so good. We set up like that.
Yes.
All right. So we got to convert the mass into grams. So we've got 0.438 pounds. Okay. So we got, I can convert pounds into, you go directly in pounds to grams. I think it's 434, but I don't know exactly. So let's just go to kilograms. I know that one. So we have 2.205 pounds per kilogram. And then kilograms go on the bottom, so they cancel. And kilo is a 10 to the third, or 1,000. 10 to the third grams. So what I've done, I've gone from pounds and then kilograms to grams. And each one of these units has to be equal to 1. There's 2.205 pounds in 1 kilogram. And there's 1,000 grams or 10 to the third gram in a kilogram. So then we just do the math. We do 0.438 divided by, it's on the bottom, 2.205 equals 0. And we're good at 31986. So 1199. And this is times for our units up here, 10 to the 3. Okay. So that's equal, that's grams. So that's equal to 199 grams. So far, so good.
Yes.
Okay, so density equals mass, which is 199 grams, because we want it in grams per milliliter, and we have a volume of 2.35 milliliters. So again, get our calculator out, and it's 199 divided by 2.35. That's equal to 84.7 grams per milliliter. That's the density of the arrowhead.
Yes.
All right, all that makes sense?
Yes.
Cool. All right. So let's go to the next question here. Now, how many atoms are present in magnesium sulfate?
6.
I can give you the formula. Mg's plus 2. Actually, that question's wrong. That's not magnesium sulfate written there. That's magnesium nitrate. Magnesium nitrate is MgNO3 twice. That's magnesium nitrate. And there's 6 oxygen atoms in that, you're right. But the answer is, says magnesium sulfate. Magnesium sulfate is MgSO4. And there's 4 oxygen atoms. So either answer 6 or 4 would be right.
Okay.
I put you see what the mistake is?
Yes.
Okay. So on your form, change that word to nitrate. And then the answer is 6. But if you want magnesium sulfate, MgSO4, because plus 2 and minus 2, it balances, then it's 4 oxygen atoms. Sorry about that. Didn't see that. Okay. What is the molecular mass or the molecular weight of potassium nitrate? What's the chemical formula for potassium nitrate?
It would be K, and that would be -1.
No, K is always positive. It's a metal. Metals are always positive.
Oh yes, +1.
Perfect. Mhm.
And then nitrate is NO3.
Yep. And what's the charge on nitrate?
-1.
So +1, -1, we're good. So we want the molecular mass. So we have 1 potassium.
Which is
We have 1 nitrogen. How many oxygens do we have?
oxygen's 3.
Right. So we have 1 potassium. Potassium weighs what?
Potassium weighs 39.
39. Perfect. We have 1 nitrogen. Right. Nitrogen weighs what?
14.
Okay. And we have 3 oxygens. Each oxygen weighs what?
16.
16. So we have 39, 14, and 16 times 3, which is 48. Yeah. We have those together. So the molecular weight should be 101 grams per mole.
Got it.
All right, perfect. Next one says balance the equation of hexane, which is C6H14, burning the presence of oxygen to produce carbon dioxide and water. So we just write that down. We are at C6H14, that's hexane. And burning in the presence of oxygen is plus O2. And it tells us it produces carbon dioxide and water. All right. Now we need to balance it.
So can we put a 3 next to the CO2?
Why 3?
Oh, actually, 6.
Right, it's the oxygen that's double, not the carbon. So you're correct. You put a 6 right here.
And the hydrogens, that's
Mhm.
14. So an 8, oh, 7.
7.
And then in front of the, oh, another 6 in front of the oxygen, would it be?
Now, how many oxygen do you have on the right-hand side?
We have 12,
Plus,
then 14.
no,
Oh, no, actually, just 7.
plus,
So it'll be 19.
right, there you go. So how to make that say 19 oxygens on the left-hand side?
So it would have to be 19 over 2.
Exactly. And then what do I do?
Multiply everything by 2.
Everything by 2. So 2 hexanes plus 19 oxygens goes to 12 CO2s plus 14 H2Os. And let's double check it. We have carbon, we have hydrogen, we have oxygen on the left side and the right side. So carbon on the left is how many?
Carbon on the left, 6.
No,
Or
There's two.
the
there's 2,
12.
right? So 12.
12.
How many on the right?
Mm, 12
12. Perfect. How many hydrogen on the left?
hydrogens. There's 14
No.
times, would it be 14 times 2?
Yep, it would be.
So it's 28.
Okay. How many on the right side?
14 times 2, 28.
Okay. And oxygen is on the left side.
Oxygens, is that 19 times 2?
Yep.
38.
Oh, 38. Yep, you're right. 36. 19 times 2 is 38. Let me just write that better. Come on, computer, catch up.
Mhm.
There you go. Oops. Get rid of the 6. It's 38. And on the right-hand side,
12 times 2 is 24.
right?
Then plus 14. That's 38.
38. Got it. Perfect. Perfectly balanced equation right there. That's what you want. And there's one more question. Okay. Potassium sulfate reacts with barium phosphate to produce potassium phosphate and a precipitate. Precipitate just means a solid of barium sulfate. So 68.7 grams potassium sulfide react with 132.8 grams of barium phosphate. What is the theoretical yield of barium sulfate? Theoretical yield just means how much you predict in your chemical equation. Because all the numbers you're doing now assumes everything goes 100% correct. Nothing goes 100% correct. So your actual yield, what you get, and your theoretical yield are going to be a little bit different, depending how good you are in the lab. All right. So what do we do?
Turn it into chemistry form.
Yep. The potassium sulfate reacts with barium phosphate. So you got to write potassium sulfate, which is what?
K plus 1, and then sulfate is is SO4
Perfect.
with -2.
Right?
So it's gonna be K2SO4.
Potassium sulfate. Perfect. Plus, what's the formula for barium phosphate?
Barium sulfate. Barium is so it'll be Ba, and then it'll be +2, and then sulfate again is the same, yes. SO4, and then is
Not SO4, phosphate.
phosphate.
Yeah. SO4 is sulfate,
PO4,
PO4.
and then that's -3. So
Right.
it's gonna be PO4 parentheses 2, and then Ba3.
Right. Okay, barium phosphate. And what's it going to form? Just look at our potassium and barium are metals. So it's going to form potassium combined with what?
Potassium phosphate.
Combined with a phosphate. Perfect. And that's going to be what?
PO4, and then potassium is a 2, and then so it'll be K3.
Okay. Perfect. Plus, and then barium what? What's the barium you combine with?
And barium Ba sulfate. So SO4.
What are the numbers there?
Would it be SO4 2 parentheses?
What's the charge on barium?
Barium is +2.
Right? Barium's +2. What's the charge on sulfate?
Sulfate is -2. Okay.
So it stays like that. Perfect. You got it. So we converted into a chemical formula. Now we need to do what to that equation?
Balance it.
Balance it. So how do we balance it?
K2 is plus, um, would we add a 3 next to the BA on the right?
Okay.
Mm. Can we put a 3 on potassium on the left, the first one, and then put a
Right.
2 in the other one,
3 here,
maybe?
and then put a 2 here.
Yes.
Okay. Then what?
And then PO4. Can we put a 2 next to BA on the left side?
Why?
Because phosphate is, there's a 2 and then there's already a 2 there.
Right.
Would it be good now or?
Sure would. That's a balanced equation.
Okay.
You got it. Very good.
Thank
Write
you.
down our numbers. Potassium barium sulfate. Okay. 68.7 grams potassium sulfate. 68.7 grams. React with 132.8 grams of barium phosphate. 132.8. And what is the yield of barium sulfate? That's what we're looking for. That's our question mark. All right. So now we got everything right in front of us of what we need to do chemically, right?
Yes.
All right. So we're going to need to get everything into moles. So we need to convert potassium sulfate into, we need a molecular weight for potassium sulfate, barium phosphate, and barium sulfate. Those 3 things, because we have to convert those into moles. So we need the molecular weights. So the molecular weight of potassium sulfate is, there's 2 potassiums, and each potassium is how much? So
My computer is gonna die.
go ahead. You're fine. Okay, got it?
Yes.
All right. So molecular weights of potassium sulfate. Potassium is 39, and there's 2 of them, so that's 78. Okay. How many sulfurs?
There is 1.
And what is sulfur weight?
Is it 1 or 3?
That's 1. We're only doing the compound, not the balanced equation yet. We're just doing the compound.
it weighs 32.
Right? And 4 oxygens is what?
16 times 4.
Yep. It's 64. So it's like 174 grams per mole, right? 10, 14, 8, 11, 17. Yep. Okay. Barium phosphate. Barium is how much?
137
37.
times 3.
Yep. 137 times 3 gives you 411. And phosphorus. How many are there?
39, there's 1. Oh, would it be 2?
It'd be 2 because of parentheses. Yep. 2 phosphorus. Each one is 31, but 62. And oxygen is how many?
So each one is 39 or 20 for K.
So for phosphorus, each one
Yeah.
is 31. Phosphorus is P,
Oh, snap.
number 15 on the periodic table.
Yes, got it.
31. Mhm. And there's 2 of them.
Okay. And then oxygen is there's 8.
Right. There's 8 oxygen. And each one is
16.
right. Comes out to so 16 times 8.
Times 8, 128.
128. Add those together.
601.
601. Okay. So know that. So now we need the molecular weight for barium sulfate. Barium we said was 137. Sulfur we said was 32. Yeah, 32. And oxygen was 16, 64, 4 of them. So 13, right? Yep, 4, 7, 13, 233. Yep. So 137, 32 from the sulfur and 64 from the oxygen because it's 233. All right.
Yes.
Okay, now we got everything we need to start the calculations. So you got to convert everything into moles because one of those is going to run out first. So convert into moles and we determine which one's going to run out first. That's what we're going to use for our calculations. So for potassium sulfate, we have got 68.7 grams. And how many grams per mole? We got 174 grams per mole. And for barium phosphate, we've got 132.8 grams. And I've got 601 grams per mole. So potassium sulfate, we have got 68.7 divided by 174 equals point, and we're good to 395. Rounding that off is 394,827. So 395. And is that what you got?
Yes.
Okay. Barium phosphate is 132.8 divided by 601. Comes out to 0.221. Wait a minute. That's 4 digits for this one. 0.220. Yeah, 0.2210. Right? 2, 3, 4. This rounds up to a 5. Is up to a 10. 0.2210. All right. There's our numbers for our moles. We have to set up our ratio, right? To see which one's going to run out first, which one's going to be our limiting reagent. Because once we run out, it stops. So which one you want to pick to make us X?
Potassium phosphate. I mean, sulfate.
Sulfate. Got it. Let's make that one as X. So we've got X over 0.2210 is going to equal, what's the ratio you're going to put here? Potassium sulfate goes on top, which is what's number from potassium sulfate?
Is it 3.2 or?
See? And then barium phosphate is 1, right? Because we're using these numbers right here. Potassium sulfate in front of the barium phosphate.
Okay.
It's a 3-to-1 ratio. So X equals 3 times 0.2 to 0.6630. Do we have 0.6630 moles of barium phosphate? No, we did potassium sulfate, right? Yeah.
Yes.
This is potassium sulfate. So do we have 0.6630 of potassium sulfate?
No.
No, we've only got 0.3, right? So we don't have enough. So this is going to be our limiting reagent. So now we know our limiting reagent. Now we just set everything up, and we already have converted into moles. So we got 0.395 moles of potassium sulfate. Okay, so what's going to go on the bottom so it cancels?
0.2. Would it be grams? No. Moles?
It has to be moles of potassium sulfate. So they cancel. Now the same thing on the top, then to the bottom of the next one. So moles of potassium sulfate. And I want to go to moles of barium sulfate, which is what I want for my answer. And what's my ratio?
Is it 2? No, it's 3. No. Yes, it's 3.2.
No, it's this number right here. 3 for the barium sulfate and potassium sulfate.
It's 3.
3 to 3.
3 to 3.
Those are the numbers on my chemical equation for barium sulfate and for potassium sulfate. So like using moles of barium sulfate. And so moles of barium sulfate have to go on the bottom. And then grams. And that's 233 grams of barium sulfate. So I've got moles potassium sulfate, moles potassium sulfate, they cancel. Moles of barium sulfate, moles of barium sulfate cancel. Are left with grams. And each one of these has to equal 1. So 3 moles of barium sulfate is going to react with 3 moles of potassium sulfate. It's a 1-to-1 ratio. 2 to 3, then every mole of barium sulfate has 233 grams. So we just do the math. Because we're left with grams of barium sulfate, which is what we are looking for right here. Okay. So let's turn this on. And 0.395 times 3 divided by 3 is 1 times 233 equals 92.0 grams of barium sulfate. And that is our final answer.